critical point, or turning point. We say that x equal a is a critical point or turning point of a function f of x if one of the following condition is satisfied. First of all, f dash a equals 0, and second, f dash a is undefined but f of x is continuous at x equal a. For example, let's take f of x equal to mod f of x, and the graph of this function will be like this. Yeah, then left hand derivative equal to -1, right hand derivative equal to +1 we obtain from this function. So the derivative f dash 0 does not exist at this point. Then on the left of x equals 0, the function is decreasing. Yes, you can see here. And on the right of x equals 0, the function is increasing. However, f of x equal x is continuous at x equal to 0. Hence, x equals 0 is a critical point of the function. F of x equal mod of x. Secondly, stationary point. Stationary points. Stationary points are defined as those points where f dash x equals 0. Yes, these are stationary points. Now we will be discussing about few examples, very important examples. Firstly, example 1. The nature is quadratic function. Yeah, quadratic function. The instruction is determine the intervals of increase and decrease of the function f of x equal x square minus 4x plus 3. Now the solution goes like this. Here f of x equal x square minus 4x plus 3. We have to find the first derivative, that is 2x minus 4, 2 times x minus 2. To find stationary points, we have f dash x equal 0. So 2 times x minus 2 equal 0, x equal 2. Hence x equal to 2 is a stationary points. Yeah. Then we have to find the intervals where the function is increasing or decreasing. So now if x is smaller than 2, then f dash x equal 2 times x minus 2 is smaller than 0. Let's check the value. X less than 2 is 1. 1 minus 2 will be negative, times 2 is negative, that's why it will be less than 0. Hence f of x is decreasing on minus infinity to 2. This gives the interval. Yeah. And if x is greater than 2, then f dash x equal 2 times x minus 2 is greater than 0. Suppose if we have taken the points 3 in this interval, 3 minus 2 will be positive, times 2 will be positive, it will be greater than 2. So hence f of x is increasing on the interval 2 comma infinity. Yes, we find here the function is, in this interval the function is decreasing, and in this interval the function is increasing. Now let's discuss second example. This is about polynomial function. Polynomial function. The instruction is determine the intervals of increase and decrease of the function. Increase and decrease of the function. And the function is f of x equal x cube minus x square minus x plus 4. The solution here, f of x equal x cube minus x square minus x plus 4. F dash x equal 3x square minus 2x minus 1. for stationary points f dash x equal to 0, then 3x square minus 2x minus 1 equal to 0. 3x square minus 3x plus x minus 1 equal to 0. 3x common, x minus 1 plus 1 common, x minus 1 equal 0. 3x plus 1, x minus 1 equal to 0. Therefore x equal minus 1 by 3 or 1. These are the stationary points, and these stationary points divide the whole real line into 3 parts, because this is the real line, minus infinitive, here minus 1 over 3, here is 1, this is one interval, this is second interval, and this is third interval. Yeah, now we have to determine f dash x sign on each of these parts. So we can make the table. Here intervals, here sign of here f dash x and nature of f of x. So the interval is before sign of, what sign of these two? Yeah, one is 3x plus 1, another is x minus 1. The intervals are, first interval is minus infinity to minus 1 over 3. At this time, if we have taken any points within this interval, we will obtain this factor is negative, this factor also negative, the product is positive or that is greater than 0. At that time the function is increasing. Let me highlight once the point. Maybe from this interval, suppose I have taken minus 2, a point. Minus 2 times 3 is minus 6, plus 1 is negative, and minus 2 minus 1 is also minus 3, which is also negative. We need to check a particular point or the points from this interval. If you have taken and we substitute the value of x here, the variable is x here, it will be 3 minus 2 is minus 6, plus 1 is minus 5, here also negative. We obtain here negative result, here also negative result. The product of this will be, this is first derivative, will be greater than 0, which is increasing function. Okay, now the second one is minus 1 over 3 comma 1. In this interval, if I have taken a point 0, okay, 0 positive, I obtain positive result, 0 here negative result, product is negative, which is smaller than 0. At this interval the function is decreasing. Yeah, similarly the last interval is 1 comma infinity. If 5, I have, suppose I have taken 5 from this interval, 5 3 is 15 plus 1 positive, 5 minus 1 is 4 positive, positive is positive greater than 0. The function is increasing in this interval. So finally uh, f of x is, therefore f of x is increasing on minus infinity minus 1 over 3 union 1 comma infinity, and decreasing on minus 1 comma 3 1 over 3 comma 1. In this way we can solve this question. Now the example 3. Example 3, here the function having a point of discontinuity. Yeah. So the instruction is determine the intervals of increase and decrease of the function f of x equal x plus 1 over x. Now the solution here, the given function is f of x equal x plus 1 over x. Yeah. Then first derivative f dash x equal, first derivative of x is 1, and derivative of 1 by x is minus 1 over x square. It can be written as x square minus 1 over x square. Yeah. So to find the stationary points f dash x equal 0. So x square minus 1 over x square equal 0. X square minus 1 equal to 0. X equal plus minus 1. Simply. Hence, x equal to 1, x equal to minus 1 are stationary points of the function. Also, we see that f of 0 does not exist, and so x equal to 0 is a point of discontinuity. Thus, x equal to minus 1, x equal to 0, and x equal to 1 are the points. So these points divides the real line into 4 parts, which is the interval, that is minus infinity to minus 1, minus 1 to 0, 0 to 1, and 1 to infinity. And intervals are sine of f dash x and the nature. So the intervals are minus infinity minus 1, x square minus 1 and x square. So these two are the factors. And if we have taken any points, suppose minus 2, minus 2 whole square is 4, minus 1 is positive, we will put it. And minus 2 whole square is also positive. Positive divided by positive is positive, which is greater than 0. The function is increasing. Similarly, the second interval is minus 1 comma 0. If we have taken any point from these minus 0.5, it will be negative and it will be positive. Positive negative is negative division, divisible by this. So less than, so decreasing. And the third one is 0 comma 1. 0.5, if I have taken 0.5, here will be negative. If we test, here will be positive, and which is negative is smaller than 0, decreasing. Finally, the last interval 1 comma infinity, if we have taken 2 to the 4 minus positive, 2 to the 4 minus 1 is positive, 2 square is also positive, the product is positive, which is greater than 0, the function is increasing in this interval. From the table, the function is increasing on minus infinity comma minus 1 union 1 comma infinity, and decreasing on minus 1 comma 0 union 0 comma 1. In this way, in case of discontinuity points also, we need to check and we need to find the intervals, and we have to find the increasing or decreasing part. Now we can see the graph of the function y equal to x plus 1 by x. This is the graph of this function. Then if we compare the result, here we can see within a interval minus infinity to minus 1 up to here, we can see it is increasing. Yeah. Then minus 1 to 0, this is decreasing. Similarly, 0 to 1 up to 1, it is also decreasing. From 1 to positive increase, positive infinity, it is increasing. So if we find the graph in this way, we can find increasing or decreasing of the function. Graphically also we can find it is true or false. Now the last example, very important example 4. This is the function having a point where the derivative is undefined. Yeah. So the instruction is determine the intervals of increase and decrease of the function f of x equal x minus 3 x to the power 1 over 3. And the solution here, f of x equal x minus 3 times x to the power 1 over 3. Now we have to find the first derivative, that is x derivative is 1 minus 3 times derivative of this is what? 1 nx n minus 1 over 3 times x to the power 1 by 3 minus 1. It will be 1 minus, it can be cancelled. This goes down by making 2 by x to the power 2 by 3. Then again we can change this 1 minus 1 over x to the power 1 by 3 whole square equal 1 plus 1 x to the power 1 over 3, 1 minus 1 over x to the power 1 over 1 by 3. These two are the factors. Now its power 2 by 3 is expressed in this way. And for the stationary point, points f dash x equal to 0. So 1 minus 1 over x to the power 2 by 3 equal to 0, and x to the power 2 over 3 minus 1 over x to the power 2 by 3 equal to 0 here, and it goes to multiply, and then x to the power 2 by 3 minus 1 equal to 0. Then what can we do? Here x to the power 2 by 3 equal to 0, then therefore x equal minus 1 and 1. Then it is clear that f dash 0 does not exist. However, the function is continuous at x equal to 0. Hence, x equal to 0 is a critical point. Thus, x equal to minus 1, x equal to plus 1, 0 are the points, and divide the whole real line into 4 parts. Yes, one is minus infinity comma minus 1, minus 1 comma 0, 0 comma 1, and 1 comma infinity. Now we now determine the sign of f dash ex one on each of these parts, yeah, and apply the test of monotonicity by checking x equal to minus 2 to the power 3, minus 2 to the power minus 3, 2 to the power minus 3, and 2 to the power 3 as a test point. Now the table. Here the interval, here the sign of, here f dash x, here nature of fx. Interval is minus infinity to minus 1. Sign is 1 minus 1 by x to the power 1 by 3. One factor is this. 1 plus 1 by x to the power 1 by 3. Another factor is this. So if we have taken minus 2 to the power 3, then as a testing point, testing value, then here we will get positive sign. Yeah, if you put minus 2 to the power 3, minus 2 to the power 3 times 1 by 3, 3 cancel, and this minus makes plus, will make plus here. Here also we will find plus value. The product is positive greater than 0, the function is increasing. You can try whether the value gives positive or not. Yeah, and the second interval is minus 1 comma 0, minus 1 comma 0. The testing value is second value. Here we will obtain positive, here we will obtain negative. The product is negative, smaller than 0, here decreasing. Similarly, third interval is 0 comma 1. Testing is this. Yes, 2 to the power minus 3, 1 by 2 to the power 3, 1 by 8, that gives the positive between this. Yeah, so here we obtain the negative result, here we obtain positive result. The product is negative, smaller than 0, the function is decreasing. Similarly, 1 to 8, if you have 2 to the power 3, here we obtain positive, here also we obtain positive result. The product is positive greater than 0, the function is increasing. Yes, now finally from the table, we see that the given function f of x is increasing on minus infinity minus 1 union 1 comma infinity, and decreasing on minus 1 comma 0 union 0 comma 1. Now let's see the graph of the function x y equal to x minus 3 times x to the power 1 by 3. The graph is like this. Yes, this is the graph of the given function. From the graph itself we can see the graph is decreasing in the interval minus infinity minus 1 up to here. Increasing, which is increasing. Then minus 1 to 0, this is decreasing. Similarly, 0 to 1 also it is decreasing. And from 1 to positive infinity, it is increasing. So we can check the graph. Yes, so graph shows it is increasing minus infinity to 1, minus 1, then minus 1 to 0, decreasing, 0 to positive 1 also decreasing, and positive 1 to plus infinity increasing. In this way, graphically also we can check whether the function is increasing or decreasing in the particular case or